Hello everybody. Today I wanted to go through trigonometric ratios, which will probably be a revision for work that you've completed in the past. So I'll just run through the different ratios for you and then we'll try a few application problems. So for trig ratios, there's three different types of ratios. One's sine, the second is cos, and the third is tan. The sine ratio is related to a triangle, a right angle triangle, which is the opposite side divided by the hypotenuse. Now in the diagram, the label diagram showing at the bottom, the opposite side is referred to as the side which is on the other side of the triangle from the angle. The adjacent side is the angle, or the side should I say, which is right next to the angle, and the hypotenuse is always opposite the 90 degrees. So if you think of a triangle as being in that position, and you could rotate the triangle around if you'd like to for the problem, then you can easily identify which one's the hypotenuse, which one's the opposite, and which one's the adjacent. The other thing you can do with this formula is you can calculate an unknown angle. We'll be looking at that during the next lesson. When you do calculations on your calculator, I've got a note there that to always set your calculator to degrees, which is a D or DEG. So calculators can be in radians and can be in gradients. So if you do your calculations with that turned on, then you'll get incorrect answers for your problems. So let's have a look at a problem. First one, example number 1. First thing to do is to identify which one of the ratios you're going to use for your problem. So for this one here, we've got the opposite side and we've got the adjacent side. So I look up at my ratios and I think opposite and adjacent, O over H, or opposite divided by adjacent. So I'm going to go with my tan ratio. So tan of theta is equal to my opposite side divided by my adjacent side. The angle is 48 degrees, so I put in, therefore, tan of 48 degrees is equal to my opposite, which is going to be x, divided by my adjacent, which is 4.2. Okay, so I've done my substitution. Now I need to try and make x the subject of the equation, or I need to move the x to the left-hand side. So the 4.2 is my problem. So if I multiply both sides by 4.2, then the 4.2 will cancel out on the right-hand side and just leave me with x. So I cancel down my 4.2 and I rewrite it as, therefore, x is equal to tan of 48 degrees multiplied by 4.2. So on your calculator, with degrees mode on, we put in tan, put in 48 degrees, and it brings up a decimal. Now, always use 4 decimal places to make your problems more accurate. So for the calculator, I got 1.106. I rounded to that. I multiply it by my 4.2, and that multiplying those to get 4.66. And of course, my units is centimetres. So the unknown length of the side for this particular triangle is 4.6 centimetres. Okay, not too hard. Let's have a look at example number 2. In example number 2, I've got my opposite side and my hypotenuse. So looking at my ratios again, my opposite and my hypotenuse is my sine ratio. So I'm going to put in sine of theta is equal to my opposite side divided by my hypotenuse. Alright, so what's my angle? 37 degrees. My opposite side I don't know, so what I'll do is I'll put an unknown in there. I'll just put that one in as, say, h for height. It could be anything, an x and a y, just any character, so that you know that it's the unknown side. And the hypotenuse side is 14 metres. So I substitute my values in, I get sine 37 degrees, and my opposite side is going to be h divided by 14, which is my hypotenuse. Now, like the previous problem, I need to make the h the subject, or move it to the left-hand side. So the 14 has to be removed from underneath the h. So like in the previous problem, I go multiply by 14, and I multiply by 14. And I end up with x is equal to sine 37 degrees multiplied by 14. Alright, so once I've got that, I can now put it in my calculator. So sine 37 degrees works out to be 0.06. Oh, sorry about that. I'll cross that out. 0.6018, and I multiply it by 14. Once again, I round it to for 4 decimal places, multiply it by 14, and I get 8.4. Round that to 3, and I've got meters is my distance. So calculation, 8.43 meters is the distance of the unknown side, which is my h. Alright, so let's have a look at this one. The next one is I've got the adjacent side and the opposite side. So this one's going to come under a tan. So tan is opposite over adjacent. So I'll go with tan of theta is equal to my opposite multiplied divided by my adjacent side. Alright, so my angle is 68 degrees, my opposite side is 12, and my adjacent I don't know, which is at x. So let's substitute those values in. Tan 68 degrees is equal to the opposite, which is 12, divided by my x. Alright, now the x is in the wrong place. It needs to be the subject. So I need to move the x to the top of my equation, the top line, and I need to move it to the left hand side. So there's 2 steps in this. First of all, I'll multiply both sides by x, and that produces x multiplied by tan 68 degrees is equal to 12. Now to remove the tan 68 degrees, I divide both sides by 68 degrees. So I divide by tan 68 degrees divided by tan 68 degrees, and I'm left with x is equal to 12, all divided by tan of 68 degrees. Alright, so what's my values for that? Well, I've got to look up tan of 68, so 12 divided by 68 degrees, tan 2.4751. I take the 12, I divide it by 2.4751, and I end up with 4.885 centimetres as my distance. Alright, so that's looking quite good. I'll go do a tan. We've done a tan at the top, a sine, and we'll do the next one. I might just change the next problem a little bit. What we'll do is we'll take this out and I'll move it around. We'll do a cosine problem rather than doing a sine problem. Okay, so let's make this side, I'll make this equal to 10. Let's put a measurement into meters, and I've got the adjacent side. So looking at my triangle, I've got my hypotenuse and I've got my adjacent. So the angle's right next to the 70 degrees. Sorry, the length's right next to the 70 degrees. So that's my adjacent, 10. My angle 70, and my unknowns, my hypotenuse. So cos of theta is equal to my opposite side, my adjacent side, divided by my hypotenuse. Therefore, cos 70 degrees, my adjacent side is 10, and my hypotenuse is an x. Now once again, the x is on the bottom. I need to move that to the top. So to move something to the top, I multiply by x. The x's cancel out, so therefore x times cos of 70 degrees is equal to 10. I need to remove the cos of 70 degrees next to the x, so I divide both sides by cos of 70 degrees. So what am I left with? X is equal to 10 divided by cos of 70 degrees. On the calculator, put 70 in. The cos of it is 0.3420. So 10 divided by 0.3420 is equal to 29.24, and I'm going to put meters in as my measurement. So looking at this, we've tried a tan, which is the opposite over the adjacent. We've had a look at a sine, which is the opposite over the hypotenuse. We looked at another tan where we had the x on the bottom, so we had to move that to the top. We did a little bit more algebraic work. And we also looked at a cos, which is the adjacent over the hypotenuse, and we had to move the x up as well. So there's some problems there out of the book. This is your John Short book, page 54. If you can work your way through those problems. The answers are in the back section of the book. And also, when you finish that, could you just try 4 more of your own choice, ones that you mightn't understand as well, so that you can sort of get a better understanding of the trig ratios. Thank you.